Hi, my name is Keaton Greeley, and I am team lead for Team Dinosaurs.
Hi, I'm Taylor Nesbitt, and I'm project manager for Team AEV Dinosaurs.
Hi, I'm Jerry Smith, and I am the lead design for Team Dinosaur.
Hi, I'm Adam Allard, and I am the lead programmer for Team Dinosaurs.
Okay, so the first thing our group had to do was come up with a few sketches. So each member of our team divided up, and we all made an initial sketch of just a basic AEV that we thought we'd use. So after we each made a sketch, we all went to class and compiled our sketches, and then we all looked at them and decided the components of each sketch that we liked the best. So then, as a group, we made another sketch that would be our initial design. We came with a pretty basic one propeller, and just an easy rectangle base so that we could fit all the parts on it. And then from that, we started to develop our designs into the other ideas.
So the requirements for this project were to create an AEV that would start at the beginning point at the end of the track, would have to start from rest, and then move to a station 3/4 of the way down the track, where it would have to stop with one wheel on the station and rest for 3.5 to 4.5 seconds. It would then have to travel another quarter of the track to pick up the caboose, which it had to rest again for 5.5 to 6.5 seconds before returning and again landing at least one wheel on the station. Now, there are several ways to complete this. First, we had a constant velocity for our propeller, and then we added a brake in to stop it. This was fairly consistent, but we just found that it used a lot of energy. So after we noticed how much energy our brake was using, we then moved to try and remove the brake. To do this, we had to simply consistently get our AEV to coast onto the station. We found that this would work fairly well with back-to-back runs, but if we were to charge a battery, it would sometimes go over our marks. So that was a pretty big problem. Another thing, after we got it down pretty consistent, we completed all of the objectives. We then moved to refine our script to make our AEV a lot more efficient. To do this, we started experimenting with our propulsion. For one, we wanted to, instead of a constant push, we wanted to have a short burst of push from the propeller. We found that this used a lot less energy, up to about 50% reduction in the energy used. So at first, we tried to not use a brake, as we thought this would use unnecessary energy. But then we moved to adding a brake, which added a ton of consistency, while not using up too much energy. So we ended up choosing to have a brake in over not having a brake for this reason.
Okay, to reflect on our entire experience with the AEV, I'd like to just talk about how we went through the engineering design process The engineering design process that we use at Ohio State first starts out by defining the problem. And our problem was basically just get the AEV from this point, move to here, and pick up a caboose, and then move it back to a certain point. Now, through that, we had to go through the requirements. That's the second part of the design process. And the requirements was stated earlier. It was the various parts of the track that we had to stop at and the times. And then once we knew the requirements, we went into designing and brainstorming, and we did a lot of brainstorming, and we actually came up with a very simple design, but the thought behind that was that we were just going to use less energy due to this simple design. Then once we had the design, we built the program, and we built the design and the prototype, and we just continued to test it and continued to improve the program once we had the final testing of the design made. So in the end, we were very successful and very proud of how our group carried through this process.
Okay. Our team took away a few key messages as a result of this project. So first off, because this was a team project, one of the biggest things we learned was to communicate. We had to communicate ideas and details of the project, like when things were due and who was doing what. So communication was key in order to get things done on time and efficiently. And perhaps the biggest thing that we learned was that nothing works perfectly the first time. For instance, our program, we went through modifications throughout the whole process by testing it on the track, editing it, testing again, until we finally got a program that we liked the most. And also, as project manager, I was in charge of the schedule, which was constantly evolving, so I always had to be up to date with what was due and who was doing what in order to make sure that everything was done on time. And finally, our team's persistence throughout the project is probably what helped us have such a great AEV with having the least amount of energy in the class. And everyone got along great, so I'd say we had a pretty successful group.
To conclude, I'd just like to talk about our results for our AEV testing. We scored 50 out of 50. We fortunately stopped at every single stop and met every requirement, and we got a perfect score. That's awesome. For the results of the class, we were number 1 in least amount of energy usage with 28 joules. We were second in ratio, and we were fortunate and lucky enough to be selected for best documentation and best engineered, and we go to the showcase tomorrow. And I just want to say that I am very happy with our results, and I couldn't have worked with a better group of people.